Okay, this is part 150. It's line 18A, 3z2a4. Graphite plasma, leptogenesis neutrinos split 4 quarks, UFO 5G Wow Seti. Again, when you see the UFO 5G, you know there is a function of some sort, or a fraction, or a formula in the video, okay? That's one of the reasons why it's there. Another reason would be it's talking about actual UFOs, okay? So this is the Wow Seti alien signal there. And I got this picture here of graphite sheet warpage and bond breakage under high heat 1000K, or 10,000K, sorry. It says graphite sheet molecular dynamics simulations were used to investigate high temperature behavior of graphite in order to examine how carbon nanotubes are formed in plasma. Again, carbon nanotubes and plasma are two of the things that come up in the calculations, okay? So this sheet heated to 10,000 Kelvin exhibited extreme warping and breaking of atom bonds. That's what it looked like. And that's from www.csm.ornl.gov. Okay, so we've got a PDF file coming up here. And it's this one here. And it's the late time particle emission from laser produced graphite plasma from SS Harilal A, Hassanein, and M. Polek. School of Nuclear Engineering, Center for Materials Under Extreme Environment, Purdue University, from Indiana. And it looks like they put it up online on September 6, 2011. And it says, we report a late-time fireworks-like particle emission from laser-produced graphite plasma during its evolution. Plasmas were produced using graphite targets excited with 1064 Nm, Nd, yttrium, aluminum garnet, sorry, don't know how to say that there, YAG laser, and vacuum. The time evolution of graphite plasma was investigated using fast-gated imaging and visible emission spectroscopy. I'm sorry. Having trouble talking today. The emission dynamics of plasma is rapidly changing with time, and the delayed firework-like emission from the graphite target followed a black body curve. Our studies indicated that such firework-like emission is strongly dependent on our target material properties and explained due to material spallation caused by overheating the trapped gases through thermal diffusion along the layer structures of graphite. And that was published in the American Institute of Physics. And I've got another little graph here for you. This is an STM image of graphite. I did a Google image to see what graphite looked like, and this is all that I could find. So I don't even know if it's in relation to this experiment or not. Okay? So a hexagonal unit cell of graphite has 2 atoms in its bases, but STM only shows one of the 2, forming a triangular lattice BAFM image of graphite. The hexagonal carbon rings are visible, and the complete surface lattice is imaged. Okay? And that's from physicsworld.com. So my thoughts, February 21st, 2012. Quote, we report a late-time fireworks-like particle emission from laser-produced graphite plasma during its evolution. Okay, so plasmas were produced using graphite targets excited with 1064 Nm, Nd, yttrium, aluminum garnet, YAG laser, and vacuum. The source of the quote is from the late-time particle emission from laser-produced graphite plasma, and it says, my thoughts continued. I see the word graphite, and this is in the carbon nanotubes plus mirrors formula for the space elevator in lines 18O, 18P, and 18Q. And it is also mentioned in the hydrogen storage tank theories and inventions in lines 18 data. So I googled graphite plasma, and my thoughts continued. I found it created fireworks when colliding laser-produced graphite plasma with particles in these test results. New formula to test my theory that neutrinos split into 4 quarks. Take your graphite plasma experiment listed here, add the neutrinos, add the protons, add the leptogenesis, equals 4 quarks hidden particles, plus sparkle at CERN Gran Sasso testing facility. February 21st, 2012, I did a Google search to check the spelling of leptonization splits neutrinos and found out the actual term is leptogenesis, and this test result paper came up. Split neutrinos leptogenesis from a3z2a4 says high energy physics, phenomenology, split neutrinos, leptogenesis, dark matter, and inflation. It's from Anupam Mazumar and Stefano Morisi. Submitted January 30th, 2012. So again, this is only about 3 weeks old. We propose a simple framework to split neutrinos with a slight departure from tribimaximal mixing, where 2 of the neutrinos are Marjorna type, which provide thermoleptogenesis. The direct neutrino with a tiny Yukawa coupling explains primordial inflation, and the cosmic microwave background radiation, where the inflaton is the gauge invariant flat direct. So I looked up inflaton because I didn't know what it meant. It says the inflaton is the name given in the form of matter responsible for the cosmic inflation, a time when the world grows so huge. Okay, so the observed baryon asymmetry and the scale of inflation are intimately tied to the observed reactor angle, which can be further constrained by the LHC and the neutronless double beta decay experiments. The model also provides the lightest right-handed S neutrino as part of the inflaton to be the dark matter candidate. Okay, and that's at argz.org. February 21st, 2012, my thoughts. It's pretty cool to have an idea about something and slowly find the data to back it up. I can see it's coming around for us. Neutrinos should be able to split into 4 quarks. Or maybe I should be saying 4 particles using leptogenesis and the methods provided in line 18A's data. Eventually, with the Wow Seti data, I should be able to come up with a plan on just how to do it. If not, I'll keep looking for test results stating that someone already has a theory about how to do it, or the test results to prove that it's true. Okay, and that's the end of that video.